Stacy from Always Eclectic Stacy. And today, now that we have all of these leftover Easter eggs, we're going to learn how to make them into a fun, hands-on learning science experience. Let's go. Okay, the materials you're going to need for this setup or this experience is a periodic table. I have one. It was $4.99 from Amazon. It's the Quick Study Science. I really like this one because it has all the different naturally occurring isotopes and their percentages up here. So if you have a high schooler or a middle schooler going into high school, this is great. But if you're looking for, an alternative key table, and is a great way of getting a periodic table. There's also really great online ones. You can just write Google periodic table. Please know that there are naturally occurring differences in the atomic masses of a lot of the elements in the periodic table due to differences in rounding and significant figures, and that's okay. We science teachers are aware. If you're doing this for a science class, please make sure you ask your teacher which periodic table he or she prefers you use. You're also going to need Easter eggs. It doesn't matter if they're the side crack or the open crack. You just need Easter eggs. I did 10. This is an experiment that I actually did with my students in a lab, because labs don't always have to be chemicals for science. Sometimes they're a hands-on learning experience. I went to, I think it was Party City, and I got these nice large eggs to hold the other eggs in. You don't have to go that fancy. I was doing it for sets of 10 for a class, so I did that. And a marker, because I number each egg so that we know what we're doing. You're also going to need either some pony beads of 3 different colors, or different counting items. They can be dyed beans, they can be pom-poms, they can be whatever you want. You just need 3 different colors of them and a fairly large quantity. Okay, let's start looking at how we can do this really fun experiment in determining eggs and atoms. And parents, please set these up before your kids get on them so they don't know the answers. If you're a teacher, I can tell you some different modifications. I'm going to tell you anyhow. So the goal of this experiment is or hands-on experience, is for students or kids to really be able to get their hands on an atom. Atoms are, we use a quantum model now, or the cloud model as a lot of people call it. And you see a lot of atoms floating around. Students have a really hard time sometimes getting their heads wrapped around the pieces of an atom. And that would be your protons, your neutrons, and your electrons, and how they interact together. So this is a hands-on experience. So what you do is you can look at your periodic table, and if you're not familiar with the periodic table, it's ordered by atomic number. So the one here in my periodic table for hydrogen, that tells me how many protons and electrons they have. So hydrogen has 1 proton and 1 electron because they come in pairs. There's always an equal amount of protons and electrons. Then you have neutrons, and neutrons can change, and that's what makes an isotope. So an isotope may have more or less neutrons than the other elements in its family. Or so hydrogen 1, that's the mass of 1, would have no neutrons. Hydrogen 2 would have 1. And how do you determine the neutron? Well, you take your atomic mass, and you can round up, because remember, we can't do partial neutrons. So hydrogen 1 has an atomic mass of 1, and it has an atomic number of 1, so 1 minus 1 is 0. Helium has an atomic mass of 4.003. If you're looking at natural occurring isotopes, is helium 4, so it's 4 minus 2 gives you, because the atomic number of helium is 2, so 4 minus 2 gives you 2 neutrons. And that also means that you have 2 protons and 2 electrons. So oftentimes with my high school students, I'll make these eggs, and we've already kind of been introduced to the periodic table, so now I'm having them use these eggs to try to determine the proton, what the isotope is. So what you're gonna do is pick any two colors, and they're gonna be the same amount in the egg, and you're gonna put them in. So for me, my reds and my whites were my protons and electrons. It doesn't matter which one because they're the same amount. So part of the challenge is for your kids to figure out which are the protons, which are the electrons, and which are your neutrons. And then once they figure that out, it's important. So you can count, and then they're using the other color or the other items that are your neutrons are going to be the deciding factor. So what they had to do was figure out the element. They would do that by determining the number of protons and electrons, and that's based on the number you put in. The number you're putting in your egg is going to be your atomic number. So I pulled egg 6. So let's count. I have 1, 2, 3, 4, 5, 6, 7, 8 white beads. Those were my protons or electrons. So 8 gives me an atomic number of 8, which tells me it's oxygen. So I have 8 white beads. That means I should also have 8 red beads if I counted correctly, and I do have 1, 2, 3, 4, 5, 6, 7, 8. Perfect, and I have 8 red beads. Now that we know the element, which is oxygen, they can then count the blue beads. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 neutrons. So they could figure out that this is an isotope of oxygen because of the amount of red or white beads, and that 8 plus 10 is 18, so it's oxygen 18. That is the mass of the isotope. That is a higher level, and all of these have similar ones. That's very high level. What happens if you have an 8th grader, hi kitty, that maybe is just being introduced to the periodic table? You could just put in and tell them that it's just protons, and have them count the protons and look up the matching element on the periodic table. You might just put in, for an adaptation, you might just put in protons and neutrons so they can learn how to do the atomic mass, because it's a really big thing in chemistry and the next generation science standards. You might have them make their own eggs and beads and then pass them around to their classmates as a kind of a jigsaw, do-it-yourself type of experience. For the younger students, they start being introduced to the atom really young these days. You might just start using it as pieces and modeling the different parts of the atom. But now that we have eggs, you can really do this. It's easy to set up. You just need pony beads and things, and then you can have them do a hands-on learning experience. My only recommendation is the first time I did this, I did hydrogen 2, but it's 1, 1, and 1, and students couldn't figure out which the colors were. So make sure that at least for your first egg, it's something that they can figure it out. The first time I did that, so I always have them start with a different egg now. If you have any questions, let me know. Please don't forget to hit like and subscribe, and come back here for more new, fresh, always Eclectic Stacy content.